Me skipping those two sections means that our chapter is going to go by faster. All right, just so you guys know that. All right, so we are going to be working on Chapter 3, Section 4. What we're going to start talking about is stuff that we need for our linear equations. So we're going to be finding slope and rate of change. Okay, when we talk about slope is it's the pitch or steepness of a line. It's the pitch of a line or the steepness of a line. All right. The higher the slope, the steeper the line. The higher the slope, the steeper the line. All right, so I'm just going to give you a graph, and we're going to talk about how to find slope. All right, so we're just going to use an example. I'm going to put the graph kind of off to the left, and I'm going to make some notes and stuff to go with it off to the right in finding slope. So you do need your rulers. For this whole, from now on for a while, have your rulers out. God bless you. All right, so I want to find the slope of this line. So we want to find slope. I'm going to show you how you can find it on a graph, and I'm going to show you how you can find it if you're just given the 2 points and no graph. All right, so let's call this bottom point A and this top point B. What's the coordinate point for A? What's the coordinate point for A? Rafaela? -4, 2. Somebody tell me, what's the coordinate point for B? What's the coordinate point for B? Seamus? 2, 4. Okay. So slope is given the variable m. I don't know why. You just have to go with it. All right, so it's m. All right, our slope, or m, it is the vertical change over the horizontal change. And this is between 2 points. I'm going to write here between 2 points. That's what slope is. It's the vertical change divided by the horizontal change, and this is between 2 points. All right, when we have a graph, your slope is your rise over your run. That's the formula. All right, it's your rise over your run, your vertical change over your horizontal change. All right, so let's just say I'm going to find our slope. So let's say I start with my A. I have to go up 2, and to the right 1, 2, 3, 4, 5, 6. I started with my A, and I found the vertical change that I have to go up, and then the horizontal change I have to go over to get to my B. All right, up is always positive, to the right is always positive. so my slope, I'm just going to do this in pink, is 2 over 6, which is 1/3. Now, I could have started at my B, and I would go down 2, so that's a -2, and I would go back 1, 2, 3, 4, 5, 6, which is a -6. So it doesn't matter which point you start with. So if I did this in green, it would be a -2 over a -6, which is still 1/3. So on a graph, it's just a matter of finding your rise, starting with one point, and either going up or down to get to the next point, and either left or right to get to the next point. You guys cool with what rise and run are? Okay. All right. If we didn't have a graph, so I'm going to say no graph. All right, we can use a formula. All right, my slope is equal to y2 minus y1 over x2 minus x1. All right, so we don't have a graph. What we have to use is our coordinate points. So take one of those coordinate points, make it your x1, y1, make the other one your x2, y2. It doesn't matter. It's like where you start graphically. So if we started at A, we're finding our horizontal change starting at A to B, and we're finding our vertical change going from A to B. All right, so what I'm going to do is, it doesn't matter which is your x1, y1, it doesn't matter which is your x2, y2. So I'm just going to go x1, y1 on that top, and x2, y2 on that bottom. And I do suggest you do label these, because it's really easy just to fall back on, I always want my bigger minus my smaller. And it's not true. Whatever point you start subtracting your y from, you have to use the same point to start subtracting your x from. You have to. All right, so if I put this in, my y2 is 4, minus my y1 is 2, divided by my x1, or my x2, which is 2, minus my -4, which was my x1. So it's y2 minus y1 over x2 minus x1. It's really important you label these so you know that I started from my 2, 4 from my y, which means I have to start from my 2, 4 and my x as well. So now I'm just going to go ahead and do this math. So I got 4 minus 2, which is 2. 2 minus a -4, which is 2 plus 4, which is 6, which gives me my 1/3. You guys cool? So you have two ways to find slope. If you're given a graph, dear Lord, just find the rise and run. It's so much faster. But if you're not given a graph, don't graph it. That's going to take too long. Just use this formula. All right, so I'm going to give you guys another set of points that I want you to find the slope from. So here's my example. Always write the formula down before you use it. You'll never forget it. All right, I want you to find the slope. The slope of the line. That runs through 9/2, 5, and 1/2, -3. All right, somebody help me out here. What did you label as your x1, y1? What did you label as your x2, y2? Come on, someone do this for me. Carmen, what did you label?
So,
my x1, y1. So which one did you label as your first point? Did you make it the 9/2 or the 1/2? Okay, so this was your x1 and your y1. This was your x2 and your y2. Okay, so now do my substitute in. So what did you have? You had -3 minus what? Okay, so what do you have? -3 minus what?
1/2.
No, it's not. You have to have y2 minus y1. So it would have to be -3 minus 5, right? And then 1/2 minus 9/2. Or if you did that as decimals, that's fine. So I'm going to do adding the opposite here. So -3 plus a -5 is a -8. All right, this is going to be a negative. This is going to be a negative. I'm just thinking a -8/2, right? Do you guys agree with that? Okay, so I had you do this one because this is funky looking, isn't it? Okay, so when we talk about slope, it's either going to be an integer or it's going to be an improper fraction. So our slope has to be either an integer or it has to be an improper fraction. So if I take a look at this, well, what I need to see is I have -8/1 divided by a -8/2. So this is the same thing as -8 times 2/8. So what is my actual slope here then? If I multiply -8 times 2/8, what do I get? Rita? No, I don't get -4. If I have -8/1 times 2/8, divide out common factors, you guys, come on. What do I get as my slope, Ryan? 2. This equals 2. Because these divide out and I get a 2. So my slope here is 2. So when we're doing slope, you want either an integer or an improper fraction as your slope. So that one was kind of funky looking, wasn't it? All right, let me give you guys another one. Yes? You could set that. Yes, you absolutely could. I didn't think about it. Yes. Okay. So I want you to find the slope of this line. So I want you to find the slope of this line that runs through those 2 points. So you're given a graph. So you should simply be using rise over run. That's your formula. Write that down. Anytime you have a graph and you're finding slope, write m equals rise over run. All right, somebody tell me, what did you do? Giselle, what'd you do? Okay, so you went from, you started here? So you went 1, 2, 3. You guys, I do want to see the lines here. So this is 3, okay? 1, 2, 3, 4, 5, 6. So that's negative 6. So what did you find as your slope then? It's going down. Aren't I going down? Remember, down is negative, up is positive, to the right is positive, to the left is negative. Right, so once Giselle decided to start on that top one, all right, I have to follow that path to the right, which is positive, and down, which is negative. So tell me what put in those numbers into my equation here. What does rise indicate? Vertical change or horizontal change? So that rise is always your vertical change. So this is your up or down. Your run is your horizontal. That is your right or left. So say it again. Excellent. Which simplifies to negative 2. Excellent. This is new to you guys. I want you making mistakes with me here. That's a good thing. All right, so this is an example how to find them using the slope, rise over run, versus the equation. All right. What do you notice in our first one? What was our slope? In the first one that we did, what was our slope? This one here. L? What was our slope? 1/3. All right. In this one right here, what was our slope? This is not a trick question, I promise. Natalie? Negative 2. Okay. Visually, what's the difference between these two? Visually, what's the difference between this line and this line? Joseph? One's going up and one's going down. Okay, so tell me, the one that's going up, remember that's from left to right going up, what's the sign of the slope? What was the sign of the slope of the one that was going up from left to right? Brian? Positive. What was the sign of the slope that was going down from left to right? Lily? Negative. That is not a coincidence. All right, so when we have positive slopes, it's always, I'm just going to do just this little quick graph here. You're always going to have the line going up from left to right. when we have negative slopes. So when you're finding slope of a line, I want you to anticipate what the sign of that slope, the slope should be. I want you to anticipate, should I be ending up with a negative slope? Should I be ending up with a positive slope? Because it's super easy to mix up which ones you start with. For example, Giselle did the one we just did. She had us find the slope of this line. But what we had to remember is when we go down, it is positive, or is negative. If you had put a positive in, we would have had a positive 2 for our slope. And you look at it and be like, no, I totally did something wrong. That has to be negative. It's going down from left to right. All right, so anticipate what the sign of your slope should be. Because that's kind of a double check. Did I do my math right? All right, you cool so far? Okay, so what I want you to do is I want you to find the slope of the line that passes through negative 2, 4 and 4, 4. So I want you to find that slope. When you're done finding the slope, I want you to graph those points. I know that seems backwards, but I want you to find the slope first, and then I want you to graph those 2 points, because I want you to see what that line looks like. So don't forget, write that formula down that you're using. Since it's not a graph that we're going from, it's that y2 minus y1 over x2 minus x1. Label your points with x2, x1, y1, x2, y2 to make sure that you're doing it right. Once you find the slope, graph that. Graph those points. I know. This is kind of funky this one, isn't it? Yep. Graph it. See what it means. These are your x's, those are your y's. So flip them. Yep. And then draw your line through those points to see what that line looks like. So, you feeling better?
Yeah.
A little bit?
I thought I was, and then I couldn't score. I feel like sick of that.
Well, I feel like when you're in school, you're always on the go, though. When you're at home, you're just kind of sitting and relaxing.
I didn't keep up.
Good. Good. All right, so let's find our slope. It's y2 minus y1 over x2 minus x1. And by the way, you could do y1 minus y2. Like, it doesn't, this is just what they say, but you could do y1 minus y2, x1 minus x2, as long as you're sticking with the same ones that you're starting from. All right, I'm just going to make my x1, y1 the 2 4s, and the x2, y2 the other one. It does not matter. All right, so I'm going to do 4 minus 4 over 4 minus negative 2. I flip-flopped them, but that's okay. And I end up with 0 over 6. If you did it the other way, I think you got 0 over negative 6. It doesn't matter. So what's my slope? If my slope is 0 over 6, what is my slope? Joseph? 0. So when I graph these, negative 2, 1, 2, 3, 4, what kind of line did I come up with when I graphed these? What kind of line did I come up with when I graphed these, Ryan? Not a parallel line. All lines are straight. Horizontal. This is a horizontal line. Why does it make sense that I have a 0 in my numerator? Why does it make sense that I have a 0 in my numerator? Lily? Exactly. That means I have no vertical change at all. So this 0 means that there is no vertical change. Which makes sense in a horizontal line, doesn't it? All right, so I'm going to have you do the same thing again. But let me ask you guys something. If there's no horizontal change if there's no vertical change in a horizontal line, that means our numerator is 0. You guys with me? What do you anticipate you're going to see in a slope for a vertical line? What do you anticipate you're going to see in a slope for a vertical line? Elle? How many of you guys agree that that would make sense? Okay, so what I want you guys to do is I want you to do the same thing you did just for those 2 points, but the points that I want you to find the slope and graph. 3,5 and 3,1. So do the same thing you just did with the vertical line, with the horizontal one, but so find the slope and then graph. How many of you guys either got positive 4 or negative 4 over 0? Okay. Does this slope equal 0? Can I say m equals 0 here? Seamus, you're shaking your head no. Why not? Can I have 0 as a denominator? What do we call those fractions when we have 0 in the denominator? Does anyone know? If you put that in a calculator, it's going to tell you have an error. So if I throw that, some calculators say what I want it to. Not all of them. So if I put that in, it says error, divide by 0. All right. This, in some calculators, they will write, and this is what I want you having, this is undefined slope. If you put that into some calculators, it will say, Ashley, can I borrow your calculator? Sometimes it will say undefined. So 4 divided by 0. No, yours says error as well. Some of them will say undefined, but that's what the slope is. We call that undefined when we have 0 as our denominator. Why does it make sense after I graph this? Why does it make sense, 2, 3, 4, 5, that we have 0 in our denominator? Why does it make sense that we have 0 in our denominator? Rafaela? Yeah. There is no horizontal change. This is a vertical line. You guys cool with that? All right, so these are slopes. Slope is really big in linear equations. It defines the pitch of the line, or the steepness of the line. So tomorrow we're going to be talking about slope in a different way as well, and then we're going to be diving into our first linear equation, which is slope-intercept form, which relies heavily on the slope. All right, so finding the slope. You guys good? Okay, you guys can go.